Hello everyone, welcome once again. See, in the previous class we see the examples of the type integration of dx upon a sin x plus b cos x plus c, and integration of the type dx upon a sin 2x plus b cos 2x plus c. Right, now see the next type of integration is integral of the form px plus q upon ax square plus bx plus c, or px plus q upon root ax square plus bx plus c. So if we have given the function in this standard form, we have to follow these steps, right, to evaluate the integral, right. Which steps we have to follow here? See, the integral of the form integration px plus q upon x square plus bx plus c. Here p, q and a, b, c are constants, right. It is evaluated by expressing the integral in the form of integration of a into derivative of denominator divided by denominator, right. What is a here? Here a is constant, and plus b upon denominator. Here b also constant, right, for some constants a and b. That is, the numerator px plus q is replaced by capital A into derivative of denominator plus b, like this. See here, numerator equals to a into derivative of denominator plus b. We have to replace numerator like this. Like, the first integral is evaluated by putting x square plus bx plus c equals to t, right? And the second integral, first integral means this one. This is evaluated by putting x square plus bx plus c equals to t, and the second integral, this one, is evaluated by expressing the integrand in the form of either 1 upon a square plus t square, or 1 upon t square minus a square, or 1 upon a square minus t square, and applying the standard formula to evaluate that integral, right. So what is next steps we have to do in this example? See, the integral of the form, another form, that is px plus q upon root x square plus bx plus c, is evaluated by, again in the same way, expressing numerator, that is px plus q, as capital A into derivative of x square plus bx plus c, that is denominator plus b. Again a and b are the constants. We have to find the value of a and b by simplifying that. And again the first integral is evaluated by substitution, and the second integral is evaluated by using these formulas, right. So in this way we have to solve the examples of this type, right. So see the example of this type, that is, these examples are very lengthy, काफ़ी बड़े बड़े examples है, तो try to see in your textbook, because here font size is very small. This is the problem actually, but try to see the solution in your textbook. There is given that solution, and hear my voice very carefully, right. See, example is this: evaluate integration twice x minus 3 upon 3x square plus 4x plus 5. Actually this is in the form of px plus q upon x square plus bx plus c. This is a standard form, right. Now, as steps involved in this type, we have to replace numerator as a into derivative of denominator plus b. That is, twice x minus 3 is replaced by capital A into derivative of 3x square plus 4x plus 5 plus capital B. Now we have to find value of a and b by equating the coefficients of like powers. That is, first of all solve this. Twice x minus 3 equals to a into derivative of 3x square 6x plus derivative of 4x is 4 plus derivative of 5 is 0 plus b, that is 6a into x plus 4a plus b is a constant. Now comparing the sides, that is the coefficients of like variable and constants from both sides. So the coefficient of x in the right side is 6a and in left side is 2. So 6a equals to 2 means a equals to 1 by 3. And constant for in the right side is 4a plus b equals to, in the left side constant is minus 3, right. So by substituting the value of a here, we got the value of b, that is minus 13 by 3. Right, now substitute this value of a and b in equation number this in the replacement of the numerator, and as by substitution value of a and b replace numerator. Right, see, it is a 1 by 3 derivative of denominator and plus b minus 13 by 3 divided by denominator. Right, now then separate the base and constant take outside the integration. So here 1 by 3 is constant, so outside the integration, and derivative of denominator upon denominator is, and minus 13 by 3 is constant in the second term, and 1 upon 3x square plus 4x plus 5, it is the second integration we get. Right, then if we see, this is actually the standard form of integration. First one, if we see that f dash x upon f of x, so we can write directly the answer, that is log of denominator actually, but here there is a solution by substitution method, but it is not mandatory, because if we see, this is the standard form of integration of f dash x upon f of x. So result of this first integral is log of 3x square plus 4x plus 5. Right, and here two integrals are obtained, so I1 and I2 are considered. I1, this is the first one, and this can be solved by substitution method, that is putting 3x square plus 4x plus 5 equals to t, and derivative of this is 6x plus 4. Right, so we got 1 by t after substitution of these things, so 1 by 3 into integration of 1 by t. Right, that is actually log of t, and t is nothing but 3x square plus 4x plus 5, that is log of 3x square plus 4x plus 5. We can write directly this answer in the first integral. Right, this should be the equation number 2. Now second integral, that is I2. What is I2? That is 13 by 3 minus actually the into integration of 1 upon 3x square plus 4x plus 5. Right, so this is the actually standard form of integration of dx upon ax square plus bx plus c. So use the step involved in that type. According to that type, first step is what? Make the coefficient of x square as 1. So for that, this 1 by 3 take constant, that is outside the integration, take common to make the coefficient of x square as 1. So we get x square plus 4 by 3x plus 5 by 3. This is the second step. 1 by 2 into coefficient of t whole square, that 1 by 2 into coefficient of x is what? That is 4 by 3 whole square. What we get then? Then we get 4 by 3 whole square means 16 by 9 into 1 by 2. Right, that is 2 by 3 whole square equals to 4 by 9. So add and subtract this term in the denominator. So we get 13 by 9, this one 13 by 3 into 1 by 3, that is 13 by 9, into integration of 1 upon x square plus 4 by 3x plus this 4 by 9 and minus 4 by 9. This should be add and subtract in denominator, plus 5 by 3. Then simplify here. What do we get? X square plus 4 by 3x plus 4 by 9 and minus 4 by 9 plus 5 by 3, that is plus 11 by 9. Then this first three terms are the perfect square of x plus 2 by 3 whole square, and 11 by 9 in square form is root 11 by 3 whole square. Then this is the actually standard form we get, that integration of 1 upon x square plus a square. So according to that, it is 1 upon a tan inverse x by a plus c. Use this result here. What we get is 13 by 9 into 1 upon a means root 11 by 3 tan inverse x is what? X plus 2 by 3 upon root 11 by 3, that is a, plus c2. c2 is nothing but the constant of integration used here. Right, then what do we get? See, therefore this is 13 divided by 9 by 3 means 3 root 11 into tan inverse thrice x plus 2 by 3 divided by root 11 by 3. 3 cancel. So thrice x plus 2 by 3, thrice x plus 2 divided by root 11 plus c2 is again constant. Now substitute this value of equation 2 and 3, that is in equation number 1, that is the results of the first and second integration. So finally what we get? First integral is 1 by 3 log of 3x square plus 4x plus 5, and second one is what, minus 13 by root 3 root 11 into tan inverse 3x plus 2 divided by root 11 plus c, where c is again constant of integration, that is c1 plus c2 equals to c. So this is the final answer for this example. It's a very long example is there, so try to understand this. And now see the next type of example, that is integration of root x minus 5 upon x minus 70x, right? This is not in the standard form, so we have to simplify to convert into the standard form first of all, and then follow the steps involving that type which is obtained, right? So for that here we have to rationalize this numerator, that is root x minus 5 upon x minus 7 into x minus 5 upon x minus 5. So multiply and divide by x minus 5. So numerator is a into a means x minus 5 whole square, and denominator is x into x square minus 5x minus 7x minus 12x, and minus 7 into minus 5, that is 35. Right. Now if we see, this is the standard form of bx plus q upon root ax square plus bx plus c, because in numerator square root and square get cancelled. So we got the term as x minus 5 upon root x square minus 12x plus 35. That is the standard form of bx plus q upon root x square plus bx plus c. Right. So now follow the steps involving that type, that is replace numerator, that is x minus 5, as a into derivative of denominator plus b, that is equals to a into derivative of x square is twice x, and minus derivative of 12x is minus 12 plus b. So here 12ax plus minus 12a plus b. By equating the coefficients of like powers, what we get, twice a equals to 1 and minus 12a plus b equals to minus 5. So a equals to 1 by 12, b equals to 1 after simplifying this, right? Then replace a and b, and replace in numerator like this. So what we get, 1 by 2, that is a into derivative of denominator plus b upon this root x square minus 12x plus 35, right? Then after separation of the base and take constant outside the integral, what we get, 1 by 2 integration of derivative of x square minus 12x plus 35 upon root x square minus 12x plus 35 plus integration 1 upon root x square minus 12x plus 35. Right? Again consider as I1 and I2. So I1 is 1 by 2 of this derivative of x square minus 12x plus 35, that is twice x minus 12. Then put x square minus 12x plus 35 equals to t. The derivative of this is twice x minus 12 into dx equals to dt. After substitution we get I1 as 1 by 2 integration of 1 by root t, right? This 2 take inside, to what we get, integration 1 by 2 root t. The result of this integration is root t plus c, right? Again c, instead of c we take c1 here, because the second integration is again there. So c1 is constant of integration. Then see the next integration, that is I2, that is integration of 1 upon root x square minus 12x plus 35. Again see the steps involved in that type is make the coefficient of x square is 1, here already 1. Then second step is what, x coefficient of x, that is minus 12 divided by 2, minus 6 square is what, 36, right? So 36 add and minus 36. Minus 36 plus 35 is minus 1. So these first three terms are the perfect square of x minus 6 whole square, and minus 1 in square form is 1 square. Right? Now this is the result of 1 upon root x square minus a square, that is log of x plus root x square minus a square plus c. This is the result of that integration. So use this formula here again. What do we get? Log of x means x minus 6 plus root x square x minus 6 whole square minus 1 plus c2. Again c2 is the constant of integration. So log of x minus 6 plus This is nothing but root x square minus 12x plus 35. Now substitute these two integrals, that is I1 and I2, in the first one. What do we get? This is the I1, that is root x square minus 12x plus 35 plus log of x minus 6 plus root x square minus 12x plus 35 plus c. Again c is nothing but c1 plus c2. So in this way we simplify this type of example, right? This is the actually final answer, right? Try to understand the next example also. This is the activity, try to done yourself, this one, that is root 8 minus x upon x. Try to solve this as the previous example, right? Then see the next one, that is it is our last example of this type is this, and try to solve the examples of exercise also, that is 3.2, right? Then in the next class we see the next step of integration, that is integration by parts, right? There is a theorem of the type integration by parts, so this will we take in the next class. Try to complete the examples of the this type.